Hi, in this video, I will be doing applications with exponential functions. So one of the first applications of exponential functions is the compound interest formula. We have an initial amount or an initial deposit or a principal that earns a certain interest rate that we call R, and we want to find the amount after a number of years. So this is the amount in the account. That's going to be the principal times 1 plus R, where R must be written in decimal form to the power of n. And in general, that's what an exponential equation looks like. But this idea of the compound interest formula, we can use it in different contexts, like population growth. So this exercise is in number 348. You are given the population in millions of a country in 2000 and 2020. So we are going to use the exponential model to find the growth rate for the specified country over this period. So we know the initial population, we know that it takes 20 years, and we know the population after 20 years. So we need to find R. And on the homework, okay, so your answer of R is going to be a decimal, and on the homework, you must write this as a percent. Okay, so this is what we have. This is the model, this is the formula that we're going to use. Where the principal is the initial population, so P70. Then we want to find R. We know that from 2000 to 2020 is 20 years, and the population after 20 years is 97 million. So we need to find R. And that R must be a percent. Okay, so let's do that. Let's plug it in. So 70 times 1 plus R to the power of n is equal to 97. We're going to solve for R. In order to solve for R, we need to divide both sides by 70. That is, we're going to pass the 70 to the other side. And then 1 plus R to the power of 20 equals 97 over 70. That means that 1 plus R is the 20th root of 97 over 70, or what is the same? This is 97 over 70 to the power of 1 over 20. Okay, so we are going to plug this in a calculator. So we have what? It's important to use grouping symbols. This is 97 divided by 70. And then to the power of 1 over 20. So that's approximately 1.016. Okay, so 1 plus R is approximately 1.016. And if you subtract 1 from both sides, R is approximately 0.016. So as a decimal, or not as a decimal, the rate is a decimal. As a percent, that's going to be 1.6%. So this is the population growth rate. Okay, so I'm going to do another example where we need to find the growth rate. This is number 59 at the end of the section on page 349. Now, this is with compound interest. So if $1,000 grows to $1,302 over 6 years, determine the interest rate during that period. When you solve the equation, you're going to get R as a decimal, and you must write the answer as a percent. So this is the formula. So we know that the principal is 1,000. The amount, the final amount is going to be 1,302. And the interest rate, not the interest rate, the number of years is 6. So let's plug it in. 1,000 times 1 plus r to the power of 6 is 1,302. Okay, divide 1,000, divide by 1,000. So 1,302 over 1,000 is 1.302. And 1 plus r is the 6th root of 1.302. So let's find this. This is 1.302 to the power of 1/6. So that's to 3 decimal, that's 1.045. Okay, just whenever you plug this in a calculator, that's the same as 1.302 to the power of 1/6. And we already found this. This is approximately 1.045. So r, subtract 1 from both sides, and r is 0.045 as a decimal, and the growth rate or the interest rate must be a percent, that's 4.5%. Okay, now, and I'll do one more example. That's example 5 of this section. So I'm going back to that page. And there it is. That's on page 343. Just as money grows exponentially in a bank account, the price of a product may increase exponentially over the years due to inflation. Suppose that in 2015, the cost of a regular tall coffee at Starbucks was $1.50, and that in 2020, the same cup of coffee cost $1.75. Develop an exponential model to describe the price of your coffee based on the information given, and use this model to estimate what you will be paying for a regular tall coffee in 2030. Okay, so we are going to find an exponential model. Y equals A times B to the power of X. So we have 2 points. So we're going to call where Y is the price. Remember the problem solving strategy, give names to unknowns, and X is the years after 2015. So in 2015, the cost of a regular tall coffee was $1.50. So when X equals 0, Y equals $1.50. And in 2020, the same cup of coffee cost $1.75. So in 2020, that's 5 years later, and Y is $1.75. So we are going to plug it into this equation. So let's plug it in. So A times B to the power of 0 is 150. But in the section about exponents, it was mentioned that any number raised to the power of 0 is 1. So B raised to the power of 0, this is 1. And A times 1 equals 150, or simply that A is 150. Okay. And then we're going to use the other piece of information. Now we know that y is 150 times b to the power of x. So we are going to use the other piece of information that they gave us. So this one, we're going to use that to find the value of b. That means 150 times b to the fifth power is 175. B to the fifth power is 175 over 150. So b is the fifth root of 175 over 150, or 175 over 150 to the power of 1/5. Okay, so let's find out. This is 175. So I didn't use the grouping symbol, so that's 175 divided by 150 to the power of 1/5. So this is approximately 1.031. And that's it. We have the exponential model. This answers part A. Y is 150 times 1.031 to the power of x. So you can also say that the growth rate or the increase rate is 3.1%, 0.031 or 3.1%. And then part B, use the model from part A to estimate what you will be paying for a regular tall coffee in 2030, where 2030 is 15 years after 2015. So 2030, it's 15 years later. And y is 150 times 1.031 to the power of 15. So we are going to round the cost to the nearest cent. This is 150 times 1.031 to the power of 15. So to the nearest cent, that's going to be $2.37. So most likely, if Starbucks is going to sell it at $2.40 rather than $2.37, but that gives us an idea. Okay, so yeah, final answer, we're going to write a statement. So in 2030, according to this model, the cost of a regular tall coffee will be $2.37. So that's it. Thank you for listening.